From 60% to 95% order visibility, how we rebuilt a logistics platform. Welcome back. Today's topic is from 60% to 95% order visibility, how we rebuilt a logistics platform. We'll cover what you actually need to know about supply chain visibility software. Now, let's talk about why supply chain visibility below 60% is a business problem. 60% visibility sounds manageable until you do the math. This client processed around 3,000 orders per week. That meant roughly 1,200 shipments at any given time where nobody on the team knew the current status without making a phone call. Customer service staff spent hours each day chasing manual updates. Warehouse teams held pick lists waiting on confirmations that arrived hours late. Carriers received the same status inquiry calls repeatedly because the client's system wasn't processing the responses their APIs were already providing. The honest answer to why this happens at mid-market scale is time. Systems accumulate gradually. A warehouse management system here, a carrier API connector there, a legacy ERP that predates the current IT team. The data exists. It just exists in the wrong places and in the wrong format. The financial impact broke into 3 categories. First, 2 full-time staff members spent most of their working hours answering "Where is my order?" queries that a properly built platform handles automatically. Second, late delivery confirmations were triggering penalty clauses in 3 major carrier contracts, adding roughly $28,000 per month in fees. Third, inventory holding costs mounted from shipments marked in transit that had actually been sitting in a regional hub for 48 hours. Next up, let's talk about how we scoped the supply chain visibility software build. Before writing any code, we ran a 5-day blueprint sprint with the client's operations director, IT lead, and 2 senior warehouse managers. The blueprint sprint methodology is a structured scoping process we run at the start of every engagement, 5 days, no assumptions, an assigned decision log before any technical work begins. The reason we insist on this approach connects to a pattern documented consistently across enterprise projects. 67% of digital transformations miss deadlines due to governance failures, not technology failures. Architecture matters far less than the clarity around what you are building and who is accountable for each decision. Day 1 covered discovery, mapping every data source, every integration point, and every business rule affecting order status. Days 2 and 3 covered architecture evaluation. We assessed 3 approaches against the client's constraints: an Azure native stack, a 2-person internal IT team, and data residency requirements tied to carrier contracts. The 3 options were event-driven messaging with Azure Service Bus, polling-based integration with Azure Logic Apps, and a hybrid of both. Next up, let's talk about the Azure architecture behind 95% supply chain visibility. The rebuilt supply chain visibility software runs entirely on Azure. We used Azure API Management as the central integration layer, with Azure Service Bus handling event-driven routing between the 4 source systems and the new visibility database. Dynamics 365 connects via the native Dataverse API. The WMS connects through its REST API secured behind the API Management Gateway. Carrier data comes through a managed Azure function polling all 12 carrier APIs on 90-second intervals. The API management layer did more than route traffic. We built transformation policies that normalized status codes across all 12 carrier systems into a single internal taxonomy. Each carrier uses different labels for identical shipment states. One calls it out for delivery, another in transit to final mile, another last mile handoff. The normalization layer maps all of these to one consistent status model that the rest of the platform operates on. One early decision that paid off later: we stored the raw, untransformed event payload alongside every normalized record. 3 weeks after go-live, one carrier updated their status code naming conventions. Because the raw payloads existed, we reprocessed historical events cleanly without any data loss or manual reconciliation. Now, let's talk about what is human-in-the-loop AI governance in software delivery. Human-in-the-loop governance is a delivery methodology where human approval is required at every decision point in the development process, not just at the final release gate. Before any AI-generated code, architecture recommendation, or configuration change is deployed, a qualified human reviews and approves it. We use human-in-the-loop AI governance on every engagement. This process does not slow teams down in practice. It catches the roughly 3% of AI outputs that are subtly wrong in ways automated testing misses. For a closer look at what those failures look like, see what happens when AI writes code and nobody reviews it. The appeal of fully automated AI development is real: faster output, lower cost per unit of code, no reviewer queue to wait on. The problem is that AI systems make confident errors. They generate code that passes all defined tests but fails on production edge cases. They recommend architectural patterns that work at small scale but degrade under load. They miss business rules that were not in the training data or the prompt context. Next up, how software delivery governance contains scope creep. Once the operations director saw live integration data in staging, she immediately wanted predictive demand forecasting added to the project. The IT lead wanted a mobile app for warehouse staff. Both are legitimate product directions. Neither was in scope. Our software delivery governance process handled this without conflict. Every new requirement goes into a decision register, is assessed against current scope, and is either formally deferred to a follow-on sprint or added with an explicit timeline and budget adjustment. Nothing disappears without explanation. It gets decided. That is the functional difference between good software project governance and managing projects by instinct. The delivery governance framework we apply rests on 4 principles: every decision is documented, every change has a named owner, every approval is time-boxed, and every deferral has a scheduled review date. Now, the results, what the numbers show after 14 weeks. 14 weeks from kickoff to production go-live. Order visibility went from 60% to 95%, measured as the percentage of in-transit orders where the system reports current status without a manual lookup. Customer service call volume dropped 61% in the first month. The 2 staff members who had been manually handling status queries were redeployed to proactive outreach, contacting customers about delays before those customers called in. Carrier penalty charges dropped to 0 in the first full month because the platform now sends automated status confirmations to carrier portals within minutes of events occurring. McKinsey research on supply chain operations consistently shows that closing real-time data gaps of this magnitude recaptures 15 to 30% of previously lost operational efficiency within the first quarter. Manual reconciliation time dropped from 40 hours per week to 4 hours. The remaining 4 hours covers cases that genuinely require human judgment: shipments with disputed customs classifications, orders flagged for investigation, carrier billing disputes. The system surfaces these clearly and routes them to the right person rather than attempting to automate them. Let's talk about now how to apply this to your supply chain platform. If your logistics or supply chain platform has significant visibility gaps, the first question is not which technology to adopt. It is whether you have a clear enough picture of where your data actually exists today. In nearly every engagement we have run, the data is already being generated somewhere. The problem is normalization, latency, and the absence of a real-time connection layer between systems. The second question is governance. AI-assisted development can accelerate delivery substantially, but only if the review process is fast enough not to become a bottleneck. Our software project governance framework is designed to provide rigorous oversight without turning every technical decision into a multi-stakeholder approval chain. An AI governance framework for logistics software delivery covers at least 4 areas. First, model selection and validation, which AI tools are approved for production use and what testing is required before any model deploys. Second, inference logging, every AI output recorded alongside its inputs for auditability. Third, human checkpoint process, who reviews what, in what format, and within what time window. Fourth, escalation protocol, what happens when a reviewer identifies a risk or disagrees with an AI recommendation. Now, next up, conclusion. Supply chain visibility software solves a real and measurable business problem, but the technical solution is only half the work. The logistics platform we rebuilt went from 60% to 95% order visibility in 14 weeks because the governance structure held the project together. The blueprint sprint methodology gave every stakeholder a shared, signed-off understanding of scope before a line of code was written. hitl workflow automation made AI-assisted development safe to use at pace. And the delivery governance framework prevented the scope drift that derails most projects of this complexity. Q Services hitl governance includes signed decision registers, time-boxed approval workflows, inference logging for every AI output, and structured sprint checkpoints. Those practices are what produced a result the client's CTO described as the first project in 5 years that delivered exactly what was promised. If your supply chain platform needs the same kind of rebuild, with the same level of accountability built in from day one, the conversation starts with your current visibility gaps and what they are actually costing you.